Good morning, good afternoon, and good evening, everyone. And thank you so much for joining me for this talk. My name is Sonal Patil. I'm a principal program manager at Microsoft in a group called Commercial Software Engineering. Today, I'm here to talk to you about DevOps and how understanding DevOps can help us implement DevOps better. So when I started with DevOps many years ago, the first question that came to my mind was, what is DevOps? I asked some colleagues who were fairly new in their DevOps adoption as well. And they told me DevOps is CI/CD pipelines, automated testing, test-driven development, etc. But I wondered, these sound like practices with practices. But is that really what DevOps is? So I went to the web, I did a web search on DevOps, and a lot of results came out. Some of them mentioned DevOps is dev and ops together. But how does automated testing fit into dev and ops together? And I still was not quite sure. So I decided to research the origin of DevOps and where this name came from. So it all kicked off somewhere in 2007, 2008. In 2009, there was an O'Reilly conference where the director of engineering, i.e. dev, and the VP of ops from Flickr did a talk called 10 plus deploys a day. The talk is on YouTube, and it's quite an entertaining watch. But what actually you see in that talk is all these practices that we take now for granted were being introduced for the very first time. In fact, this picture, Dev Heart Ops, is taken from that talk. So now I know how it all started, but what is it exactly? What is it? How can it be defined? And so I referred to a couple of books. The first book, The Phoenix Project, defines DevOps as the outcome of applying lean manufacturing principles to the IT value stream to accelerate the flow of work. The second book, The DevOps Handbook, defines ways to apply that to real software development. It defines the 3 ways and talks about the principles behind each way. This might still appear a bit too high level. There are probably some developers in the audience thinking, this is so typical of what a program manager would say. But in this talk, I try to make those connections between the principles defined in the book and the practices that we also use to. I've structured this talk to first introduce each way and then examine how certain DevOps practices contribute towards those principles. So let's start with the first way, the principle of flow. The first way asks you to establish a value stream that delivers value to the customer. Any work that delivers value to the customer is part of your value stream. Do you write automated tests? Yes. Are they going to deliver value to the customer? Yes, because the customer will see less failures when the product is in production. That's part of your value stream. Do you write infrastructure as code? Yes. Will it deliver value to the customer? Yes, because they can easily set up new environments. That's part of your value stream. The value stream goes from left to right, or from dev to ops, or from business requirements to actual customer implementations. Keeping this definition in mind, the first question I would then ask is, why do we have a sprint board? The first way tells us it's to make our work visible. Unless the work is visible, you cannot establish, neither can you optimize your value stream. This is the very basic, most starting point of your DevOps practice. This is especially important for technology work because it's more or less invisible, right? There is no car produced at the end of an assembly line. There's often friction between engineers and the managers because the managers think, why is something taking so long? It's only a few lines of code. Or the frustration you feel when you've spent 2 or 3 sprints writing a beautiful API, but you have nothing nice to demo because technology work is more or less invisible. By visualizing work on a sprint board, it helps us see where work is flowing well and where it is stalled. Also remember, work is only considered done when it's in production, delivering value to the customer. The next question I'd like to ask is, why do we work on one task at a time? That is to limit work in progress. It is proven widely that time taken to complete even simple tasks like sorting geometric shapes significantly degrades when multitasking. Picture this scenario, right? You have a project deadline and you've got many things to complete in one sprint, and you start working on all tasks at the same time. You have 6 tasks open, you're switching back and forth between bugs and new functionality. You lose your flow constantly switching back and forth. You started by wanting to finish stuff earlier, but you end up taking more time or quality suffers. Hence, you should endeavor to limit work in progress. So the next question I'd like to ask is, why do we commit small changes in pull requests? The first way tells us to reduce batch sizes. What that essentially means is to chunk your work into smaller parts and finish that part before you begin another. This results in reduced waiting time and faster delivery of value. Let me illustrate this by two flows. In the first flow, all the changes are authored, tested, and put in a group together in a code review. The pull request takes longer because there are more files to review and there may be more conflicts. The deployment takes longer because there's more configuration and again, possibly more areas of conflict. There's very long waiting time before any value is delivered to the customer. Contrast that with the second flow. Each change is committed in its own pull request. It's reviewed, tested, and deployed to production. The wait time is shorter, any problems are quickly identified, and value is delivered way quicker to the customer. The next question I would like to ask is, why do we dev test and operate our own code? Now, this appears to be a pet peeve of a lot of engineers. Why do I have to test my own code? I used to have a QA team before. Or why don't we have an ops team? Why do I have to carry a pager? Well, the first way tells us is to reduce the number of handoffs. Every time work passes from team to team, there's a lot of communications and context settings that take place. There's specifications, prioritizations, scheduling, ticketing, project management systems, documentation, meetings, emails, and whatnot. Yet, every time a handoff happens, context is lost. Each handoff is a potential queue, and each queue is a potential bottleneck. And when you have a bottleneck, the flow of work is stopped or interrupted and is not going to the customer. The next question that we'd like to examine is, why do we have CI/CD pipelines? And that is to remove constraints from the flow. I'd like to demonstrate this by bringing up this picture. This is the waterfall model. And if you're about my age, you've probably lived the dream, or should I say the nightmare. In the waterfall model, each step must happen in a specific order. So for example, I cannot start requirement specifications until I've finished analysis. So each step is a constraint for the next. With DevOps, we start removing constraints. Let's remove the one that says environment creation by writing infrastructure as code. Now the development team is not constrained by the IT infrastructure team. Next, I'm going to remove testing and integration and deployment by adding CI/CD pipelines. Now, the delivery to the customer is not constrained by sign-off from a test team, neither is it constrained by deployment by an infrastructure team. Every change that the team commits is tested and automatically deployed to production, delivering value to the customer. Let's not stop here. Let's remove some more constraints. How about design and architecture? We remove that by adding loosely coupled architecture. Now the development team is not constrained by the team of architects to hand them down their architecture diagrams. The design stays in the realm of the development team. Now, if you observe what's left, what's interesting is the only steps left here: analysis, requirement specification, and development are all the activities done by the DevOps team members, which is, say, the product owner and the developers. There aren't any external constraints. And any team that doesn't have any external constraints can maintain a good flow of work to the customer. Now that we've seen the first way, let's look at the second way. So in the first way, we established a value stream. Now we want to make it a safer, more resilient value stream. And the way we do that is by fast and constant feedback from right to left. This feedback comes not just from the customer to the business, but from all stages of the value stream. Let's look at some of the DevOps practices that help us with this feedback and how they relate to the principles. So, another question. Why do we peer review code and pull requests? Second way tells us it's to push quality closer to source. Peer reviews give us quicker, closer feedback loops. It helps us detect and remediate problems when they're actually cheaper to fix than when they get amplified in production. A stitch in time saves 9, right? Peer review makes quality everyone's responsibility instead of it being the responsibility of a QA team. And having developers share responsibility for quality not only improves outcomes, but accelerates learning as well. Another question, why do we do automated testing? And the answer to that is to see problems as they occur. If we wish to build a safe, resilient system of work, we need to constantly test not just our code, but also the design and operating assumptions. We want this to provide a shorter, quicker feedback loop. If we compare this to manufacturing cars, for example, before the adoption of lean manufacturing principles, there were instances in some car factories where there weren't any procedures in place to detect and fix issues. What this resulted in were cars that had to be towed off the assembly line because they couldn't even start because they were so badly assembled. With software development again, the end result is not as obvious as a car that won't start. What typically ends up happening is we release code into production that has bugs in it. We know it has bugs in it, but we have to release it. These get raised as priority 1 issues, and the team has to put in late nights and long hours to fix these issues and keep production going. If we do not want to have this kind of scenario again, we need to invest time into building better automated tests early in the value stream. Next question, why do we stop work to fix a failing CI/CD pipeline? I have received a lot of pushback about this. They're like, are you literally mean stop working? The whole team just stops working because build pipeline fails? Well, the second way says yes, so that we can swarm and solve the problem. It's not just sufficient to detect a problem, but when the unexpected happens, we have to mobilize, put our heads together, and fix it to get the flow of work going again. A good example is the and-on code at Toyota. In all Toyota manufacturing plants, at every work center, there is a cord that workers and managers are trained to pull if something goes wrong. For example, a part is missing or defective, or work is taking longer than expected. Once the cord is pulled, the team leader and the worker try to resolve that problem in, say, 60 seconds. But if they cannot do that, the entire production line is halted and the entire organization can be mobilized until the problem is either fixed or an acceptable countermeasure is found. Instead of working around the problem, they swarm to fix it immediately. The same principle can be applied to software development as a virtual and-on code. If a build or deployment pipeline fails, then the flow of work to production has essentially stopped and our value stream has stalled. Instead of postponing the resolution of that problem, we need to swarm together to either fix it right away or put a countermeasure in place for as long as it takes to fix it. And finally, the third way. Now that we've built a value stream, we've made it safer and more resilient, we now want to make it better and more improved. And we do that by continual learning and experimentation. We need an organizational culture of experimentation and learning, where all of us are empowered to learn from our successes and failures. And so the final question I'd like to ask is, why do we have retrospectives and sprint reviews? And this is for the improvement of daily work. Learning is not just learning new languages or new tools or new frameworks. It's about improvement of how we do work as well. There's a well-known saying that in the absence of improvement, processes don't stay the same. They degrade due to chaos. By applying the scientific method for both product development and process improvement, we learn from our successes and failures, identifying ideas that don't work and reinforcing ones that do. Remember that even more important than daily work is the improvement of daily work. So thank you so much for listening. I hope that looking at the DevOps practices from the perspective of the principles behind them will help you drive the adoption of these practices even better with your team. I would love to hear your view on why we should do DevOps and some of your experiences in implementing it. Thank you.